As we leave the 20th century, we still face the biggest problem that we had when we entered the 20th century. How did life originate on Earth?
The biggest impasse confronting evolution is the incredibly complex structure of the living cell. Every living thing on Earth is made up of cells about 1/100th of a millimeter in size. Some living things are made up of a single cell. Yet even these single-cell organisms are remarkably complex in their composition. They have complicated functions to survive, and even little motors to move. In Darwin's time, this complex structure of the cell was unknown. With the primitive microscopes of those days, cells appeared to be little more than featureless stains. However, powerful electron microscopes invented around the middle of the 20th century began revealing just how complex and organized a living cell really was. They laid bare a complexity and organization that could not be a product of chance. A living cell is comprised of thousands of tiny parts that work in harmony. To make a comparison, within the cell, there are power stations, high-tech factories, a complex data bank, huge storage systems, advanced refineries, and a seemingly conscious cell membrane that controls what enters and leaves the cell. In order for the cell to survive, all of these organelles have to exist at the same time. It is impossible that such an intricate and complex system could have emerged as a result of coincidences.
So there's a big question, if you're just kind of trying to assess how likely is it that we'd find a protein by chance with all the amino acids in that prebiotic soup interacting with each other for, say, billions of years. And I give it a lot of time. How likely is it that we'd ever get a protein to arise by chance? So I have a colleague who's been interested in the whole question of whether or not life could arise by chance for a long time. His name is Doug Axe. He's a molecular biologist. He did his PhD at Caltech. He worked for 14 years at Cambridge University, and he wanted to find out how common or how rare are the functional sequences of amino acids among the big space of all the possible amino acids there are. And he came up with a really amazing number, and it's 10 to the 74 power. So just to get the amino acid sequence properly, you've got an odds of about 1 in 10 to the 74. But there's other probabilistic hurdles that have to be overcome. If you want to build a protein, we know from chemistry that you have to attach the amino acids together with what's called a peptide bond. In nature, peptide bonds occur with about a 1 in 2 in a 1 in 2 frequency. Half the bonds that form between amino acids are peptide bonds, half aren't. But if you get any bonds forming that aren't peptide bonds, you can't form a protein. So to form a protein, 150 amino acids long, you've got a 1 in 2 chance at each site of getting the correct type of linkage. So you got 1 in 2 times 1 in 2 times 1 in 2 times 1 in 2 to the what power? Close to 150. Since we got linkages, we have 149, but call it 150, okay? So in other words, we got another huge exponential problem to overcome. So, and it turns out that 1 in 2 to the 150 is the same number as 10 to the 45th, 1 in 10 to the 45. So now we got 2 incredibly improbable things that we've got to overcome to build a functional protein by chance alone. One more problem. When you're building proteins, amino acids come in 2 flavors. There's a left-handed flavor and a right-handed flavor. They're called optical isomers, not flavors, okay? And the left-handed version is the only kind that can be used in building proteins. You get even 1 right-handed amino acid in there and your protein won't fold properly. So you got another probabilistic hurdle to overcome. So you've got a 1 in 2 chance at each side again, out to the 150th power. 2 to the 150th power, again, is 10 to the 45. Oh my goodness. So the odds of building even a short functional protein by chance alone is 74 plus 40. You can remember how you do this in math? You can add the exponents if you're multiplying exponential numbers.
164.
Thank you very much. Okay? Wow. Now, can anyone get their mind around a number that big? There's only 10 to the 80th elementary particles in the entire universe. There's only 10 to the 16th seconds since the Big Bang. There's only 10 to the 139th total events since the beginning of the universe. Now you're starting to get the understanding of why people are very skeptical that the chance hypothesis is going to do the job. Now, you may have heard just the opposite. Has anyone ever gotten in a discussion with you about the origin of life and said, hey, it happened by chance? I mean, do you hear that? I mean, this happens to me. I'll be lecturing in hostile university environments, and I'll get done and somebody say, well, but, and they want to argue with me about the probabilities. And I just shut the discussion down because I say, no serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened.
Modern biochemistry has also revealed the unimaginably complex design of the DNA molecule. The structure of the DNA molecule was discovered by two scientists, James Watson and Francis Crick, in 1955. Their discovery demonstrated that life was much more complex than anyone had previously envisioned. Himself a confirmed evolutionist, Francis Crick, who received a Nobel Prize for this discovery, came to confess that a structure like DNA could never have emerged by chance.
Professor Anthony Flew of England and Reading University is the world's foremost academic atheist over the last 50 years and the author of more than 30 books. His first debate with former atheist-turned-Christian C.S. Lewis in 1950 in Oxford, England, was the first time he advanced his argument for atheism. He later wrote a paper titled Theology and Falsification. The paper became the most widely reprinted philosophical publication of the last half-century and a key foundation for atheists and agnostics who advanced materialist evolutionism. But now it is the advancement of science itself that has changed the mind of Flew and some scientists. At a recent summit at New York University, Flew changed his position and now believes in God as the creator of the universe. Flew turns to various discoveries of science to prove his point. But it is the manifestation of life written in DNA and the transcription of DNA to RNA and RNA into protein and the subsequent process of protein folding that makes the best case for Flew.
What I think that the DNA material has done has shown by its almost unbelievable complexity of the arrangements which lead to produce this being, that intelligence must have been involved in getting these extraordinarily diverse elements to work together.
When you look at RNA, you as a chemist, you're in sort of astonishment, really, at just what a wonderful molecule it is. It's complex, it's a really beautiful structure, and you inevitably wonder, how on earth did that structure arise? How on earth did chemistry produce it?
RNA's structure looks simple, but looks can deceive. Each building block is actually made of two parts, a sugar molecule and a nuclear base.
Chemists found they could make the nuclear bases, and so when they then realized they could actually make the sugars, they just thought, we must be able to join them together. And so they tried for many years, but the problem was, chemically, you just can't join them together.
Of course, such an amazing structure could never have been formed by chance. The theory of evolution, which sees life as the result of mere coincidences and haphazard happenings, is helpless to explain anything in the face of the incredible complexity of